So today, these are the families of exponential functions. The parent function of what we're doing today is y equals b raised to the x power. We're going to take that and we're going to tell the transformations, whether it stretches, whether it compresses, whether it reflects, and the translations of left and right and up and down, horizontally and vertically. Okay, so let's look at a problem. It says y equals ab raised to the x. How does the graph of y equals negative 1/3 times 3 raised to the x compare to the graph of the parent function? So we're given this graph right here. Okay? We know when we're talking about exponential functions that our parent function is y equals ab raised to the x, or y equals bx, I'm sorry. So our parent function is y equals bx. Well, if I'm looking at something like this right here, I know that this would be my a, this would be my b, and then I'm raising it to my x power. So what would my parent function be out of this? So y equals 3 raised to the x is my parent function. Now, what's left over in the problem if I take the 3x out? That part right there, correct? So we're going to take that and we're going to tell what the transformations are. So, negative and 1/3 are two totally different things. We are not putting them together, we are separating them. What does the negative tell me I'm going to do? Flip it or reflect it. So the negative tells me I'm going to reflect it over the x-axis. Now what does the 1/3 tell me I'm going to do? Well, let's talk about it. Remember, if we go back to when we were doing transformations a chapter or two ago, if it's a is greater than 1, it is a stretch. If a is less than 1, it is a compression. Well, is a just the 1/3 now? Because the negative has nothing to do with it. Is a greater than 1 or less than 1? So what is it going to be? So I'm going to reflect it over the x-axis, and then I'm going to compress it by 1/3. That's my transformation. So let's look at another one. This one is y equals negative 0.5 times 5 raised to the x. Well, what would my parent function be? Y equals 5 raised to the x. So if I take that out of the equation, what all am I left with? Negative 0.5. That's what I'm dealing with. And it comes before the 5x, correct? So that means I'm going to compress it or stretch it or flip it or not flip it. I have to decide what. So what does the negative tell me I'm going to do? And what does the 0.5 tell me I'm going to do? Compress it. By 0.5. Now we're going to add two more things to that. So we flipped it, we've stretched it or compressed it. Now we're either going to move it left to right or up and down. So there's two things that I need to look at when I'm doing that. Horizontal shifts and vertical shifts, and they're going to look like this. So in order for it to move the graph left and right, it's going to be within the exponent. Okay? H. It's going to be within the exponent. In order to move the graph up and down, it's going to be after the exponent. So within the exponent moves it left and right. After the exponent moves it up and down. Before the parent function, it's going to be a stretch, compress, or reflect. Okay? So everything before the problem is going to reflect it, stretch it, or compress it. Everything after the problem is either going to move it left, right, up, or down. So they want to know how this graph of how does the graph of each function compare to the graph of the parent function? Well, my problem reads y equals 2 raised to the x minus 4. What if I wanted to pull the parent function out of that? What would it be? 2x. So my parent function is y raised to the 2x, correct? Y equals 2 raised to the x, I'm sorry. What's left over? My minus 4 up there, right? So something's going to move which way? Left or right? Which way is this going to move? Is it going to go left or is it going to go right? Right. Remember when we talked about that, everything in parentheses always goes opposite. So right here, this graph is going to go right 4 units. What if it would have been 2 times x plus 3? What would it have done then? It would have went left 3 units. What would it have been if it would have been y equals 2 times x minus 6? Right 6 units. Y equals 20 times a half raised to the x plus 10. What's my parent function here? So this would be a, this would be b, this would be x, and that would be my plus k back there, okay? So my parent function is a half x. What am I going to do if I take this graph right here and transform it into y equals 20 times a half raised to the x plus 10? What all do I have to do to my graph in words? Starting with the left, going to the right. A is greater than 1, so it's a. So I'm going to stretch it by 20. This right here is my parent function, so I don't need it. What else left? And then I've got to go up 10. Why am I going up instead of left or right? Because it's not in the exponent. It's after the exponent. Y equals 4 raised to the x plus 2. What's my parent function? Y equals 4 raised to the x. So what am I going to do to my parent function to achieve this graph right here? Left 2. Why am I going left? Because it's a positive 2, so I'm going to go left. It was just what you would opposite. It's the opposite of what you would think. Y equals 5 times 0.25x plus 5. What would my transformations be for this one? Stretch by what? number right there tells me that I'm going to stretch. And then up 5.